Hello, here we're going to look at 2.3, solving multi-step equations. Here's the why. As situations become more interesting and complex, we need greater abilities to solve for equations. Now, this is a little bit of looking ahead. When we're doing more complicated application problems like in physics, such as motion or position, where objects are as they move over time, or finding the area of larger shapes. So maybe think about some of the areas of your life that are a little bit more complicated than some of the initial equations we worked with, such as how much time is left in class. What are some of the other areas of your life where you're solving equations, but things get more complicated? Got a couple problems here that kind of show what this is. One would be taking the temperature formula for Celsius and kind of calculating, back and forth between, if I give you a degree in Fahrenheit, can you tell me the degree in Celsius? Or even the other way around, too. If we were going to try to, find something like this with some geometry, where we have a rectangular swimming pool and it's surrounded by a sidewalk, and it wants to find the length and width of the pool, we can do that with our information, but it's going to take a couple steps to do that. I've given us some practice problems here so that we can check these out. Now, on two-step equations, a lot of times we're going to need multiplication, division, and addition and subtraction. So on that, it's typically best, if you can, to do the addition and subtraction first. There are going to be some situations, though, where we have to do the multiplication and division first. Well, for this one here, I am ultimately going to have to divide everybody by negative 12 to help get that in by itself. But if I wanted to address this right now, I'd actually have to divide everybody by negative 12. And you can see that that's going to create some fractions if I do that. So instead, what I can try to do first is take care of the addition and subtraction, which would be adding 19 to both sides. And the reason I'm adding 19 to both sides is because this is the variable I'm trying to get by itself. So I need to remove the items that are on the same side of the equation with it. And when I add 19 to both sides, that does cancel out. And when we add it to the other side, we get a 96. Now, when I go on both sides and divide by negative 12, I get that n is equal to a negative 8. Now, notice all we did here. We just did two steps. So if you can solve a one-step equation, we can solve these as well because it's very similar. Here I added 19 on both sides, and then I divided by negative 12. So it's not too much more difficult, it's just a little bit more steps. You can see one like this, which is very similar. First steps here are going to be to subtract 17 from both sides. (14 minus 17 is negative 3. Now I'm able to divide everybody by the 3. To get that f is equal to negative 1. And just like the other day, we can check these by plugging in the numbers that we found for our variable. And when I plug in negative 1, we see that we get a true statement, which confirms for me that negative 1 is the correct answer. Taking a look at this one, or number 8, these are both fairly similar here. We see that we've got d being divided by negative 4, so hopefully you remember that means we need to multiply by a negative 4. But I don't want to do that yet, because if I multiply by -4 right now, I'd actually have to do it to both and distribute. So instead of doing that, I can leave it for my last step. So first I could subtract 3 from both sides. Now when I go to multiply both sides by -4, or if you want to think of it as a reciprocal, -4/1, I don't have as many terms to multiply everything by. I just have one term left on both sides. So get that d is equal to -48. So similarly here for for number 8, I know I'm going to need to multiply by a reciprocal right here, but I'm going to save that for last. Because otherwise, if I wanted to multiply by 5/3 right now, I'd have to do it by both the 32 and the 17. So let's wait till the second to do that. So once we add 32 to both sides, we have -17 plus 32. We get -3/5 f is equal to 15. Now we'll bring in our reciprocal skills. And we'll also need to multiply here by a negative to help the negatives cancel out. So there's the negative. So on both sides, and I'm going to be multiplying by a negative. And then to get rid of 3/5, we need to multiply by a 5/3. So the negatives cancel out, these 5's cancel out, these 3's cancel out, leaving us left over with f by itself, which was our goal. And now we'll simply multiply straight across. So if we do that, we get a -75/3. And then if I look at that, I could say, oh, well, I can do that. You know, if I had 75 cents and I divide it by 3, that's 3/4. So f ends up equaling -25. So I want us to stop and reflect here and notice that on all these problems, we did the addition and subtraction first, then took care of the multiplication. There are going to be some, though, like these two right here, which I call division prison, where we have to take care of the multiplication first. Because right now, I can't just subtract by 13. Hopefully you see why, because it's like he's currently stuck by this dividing of 12. It's like I wouldn't even really know where to write the -13 because, you know, that division of 12 is in our way. So when you see these, I call them division prison, because division is locking everybody into place. So before I can start to solve for that r by subtracting 13, I need to address the fact we're dividing by 12, which is going to be multiplying by 12. And since we see here that everybody is being divided by 12, so if I multiply everybody by 12, these just cancel out. So the division prison problems are really quite simple. You just multiply by that denominator, and then from there, you can take care of your addition and subtraction. And you can check this if you don't believe that that's the answer. If we plug in a -1 here, we get a 12/12, which gives us a 1. So 1 is equal to 1. It's a true statement, confirming that that is in fact the correct answer. Here's another one, division prison. We need to multiply both sides by 3. get rid of that denominator. I need to subtract 15 on both sides. Here's what's important to notice though. This was a subtract a, which means it carries down as a negative a. We don't have a by itself yet in this scenario. We'd have to divide both sides by -1 to finish that. So there's more to this section than that. There's a good problem here. There's some very tricky fraction ones. We've got these word problems. Let's leave this for when we're back together in person so we can ask questions and kind of piece them together. But these here are the gist of what happens in 2.3.